to be LFC of single area system, hyphen static and dynamic analysis of uncontrolled and controlled cases. So the two cases we are going to deal with the load frequency control of area system. So both controlled case as well as uncontrolled case. So once the single area is done, we are going to deal with LFC of two area system. So next one is tile line modeling, block diagram representation of two area system. So in two area system also we are going to perform static and dynamic analysis. So the tile line frequency bias control, state variable model, and the integration of economic dispatch control with LFC. So these are all the following topics we are going to deal in your unit number 2 based on your power system operational. So this unit full and full derivation and problems. So once the derivation is over, have to be discussed. So the fundamental thing which you try to for this is the unit number 1. What are the basic speed governing mechanisms you have in your unit number 1? For example, your mechanical turbine is coupled with your electrical generation. So you coupled both the devices. What are the impacts have happened? So during the normal operating conditions, as well as during transients conditions and subtransit conditions. So what are the scenarios happened in power system? We are going to discuss in terms of real power frequency control. So this is the main motive of this unit. So especially here we are able to control the real power. I'm not considering the reactive power. So reactive power is for your next unit. So certainly you have the reactive power units. So here it is real power. Only we are focusing on your real power. So in real power systems, we have 3 blocks. So one is your turbine unit, another one is your unit, and another one is plant. So 3 control system parameters we are going to take in. For that control system, we have provide the feedback. Based on your feedback system, so it is a negative feedback system. So for that negative feedback system, we have to perform your static and dynamic analysis. So I will proceed your topics. First, we are going to deal with load frequency control of single area system, static and dynamic analysis of uncontrolled as well as controlled cases. For cases, we are going to solve equations. Just derivations only we have 9 topics we have in this unit. 9 derivations முடிச்சிட்டீங்க அப்படின்னா the unit is over. First topic number 2 is frequency control of a single area system. So what is the main intention of the topic is to analyze the LFC of an isolated system and build a mathematical model from the block diagram. So here the terms we should be utilized in your control system. Del PC, incremental control output, and del PD is incremental disturbance output. So the incremental control input is the change of speed changer setting. So your turbine doesn't receive always the same speed. For example, it is hydro power station. The thing happening in hydro power station, you couldn't get the mechanical response always in a constant manner. So when the rainfall or the water is more, or when the dam is opened, you may get the sufficient mechanical power. In case of a low stream or low line of flow, you have the slow speed variation. So that speed changer is adjusted with your electrical generator. So the disturbance provided here. So based on disturbance responses, we have 2 types. One steady state or static response, and second is dynamic response. Here we have the error breaker. So the input del PC of this. So control input, I am just controlling here with the help of my error detector. And next I am connecting generator unit. So the generator, as you have find it, unit number one is kg by 1 plus STG. There's the time response, the order one. So you studying your control system paper, the term S only denotes your first order system. S square means second order system. So I just connected my first order systems for generator kg by 1 plus times of TG, and which is series with your turbine KT by 1 plus S into TG. So here my turbine and generator both are equal, so I am connecting series. So after the generator and turbine is over, I have my intelligent controller. So here I am going to apply my disturbance. So in order the speed changing process, I have the disturbance. In case of high flow or moderate flows, so it is a sort of towards I'm connecting my plant. So this is the exact mathematical model of your low frequency control of your single system. So for control system model, we are going to perform single area system and area system. This is the first topic in your unit number 2. I just all the components as a control system block. Block. So this one should be a block. So this is one block, and this is another block. And this is another block. So I'm going to play with these three parameters, the two inputs. So one is your incremental control input, del PC of S, and del is your incremental disturbance output. So for both cases, I'm going to consider the input of only the control input, and I'm going to analyze the system only with the disturbance. For the both cases, I have to analyze. So next, I am going to perform my static and dynamic analysis. So second topic is static analysis or steady state response of a single area LFC. Uncontrolled, we have two cases. One case is controlled case, another one is uncontrolled case. I am going to perform this uncontrolled case. So because the controlled case should be your open loop system. In case of your uncontrolled case, it is a closed loop. So the closed loop system analysis is somewhat tedious. So I'm going to analyze the uncontrolled case. So these are the blocks we have. I just neglecting my del PC as 0. The first diagram, yeah. So in the uncontrolled case, my incremental control input should be not connected. It is considered as 0. So 0 addition mixture gradam. G 1 plus S TG minus 1 R KT 1 plus S. Here del PT of S is equal to del PG of S. So I'm having my disturbance. So after the disturbance, I am having my T by 1 plus STP. So இது அப்படியே பார்த்தீங்கன்னா பாசிட்டிவ் ஃபீட்பேக் சிஸ்டம் போல வந்துடும். ஸோ இது வந்து உங்களுக்கு மேலே இந்த கேடி வந்து மூணுமே சீரீஸ்ல வந்துடும். ஸோ இந்த சிம்பிளிஃபைட் ஃபார்மேட் வந்து எப்படின்னு பார்த்தீங்கன்னா, ஸோ இன் திஸ் மேனர் யூ ஹாவ் த சிம்பிளிஃபைட் ஃபார்மேட். So yeah, it is a negative feedback system. So del S of S. Now it is my input. My response will be del F of S output. So what I'm trying to, I'm going to get my transfer function. So transfer function for my negative feedback system. What is the formula we have for the negative feedback system? Of S divided by 1 plus G of S H of S. So that relation you have learned in control system paper. The function for the negative feedback system. For the case of positive, it is equal to G of S by 1 minus G of S. So it is a negative feedback system, so we have plus. So what is G of S here? Kp by 1 plus Kp. What is negative? Sorry, H of S, Kg by K, R into 1 plus STG, 1 plus into Tt. So I'm just substituting the values here. So yeah, just to substitute பண்ணிருக்கேன். The G of S க்கு P by 1 plus STP, H of S க்கு K KT by R by 1 plus STG, 1 STT அப்படின்றது. சரியா? So we need answer function. One minute, might be back. I just substituted in the feedback system. That is G of 1 plus of a set of a substitute பண்ணிருக்கேன். So my minus of del PD P of S is nothing but my input. So your response del F of S divided by P of S. So I'm bringing my del PD of S is in the right hand. So இதை further I simplify பண்றேன்ப்பா. Just playing and dividing and all the simplifications of made. So Kp divided by 1 plus S into Tp plus Kp Kg Kt divided by R into 1 STG 1 plus S into Tt. So for a step load change, I am going to just apply my step. So step means 1 by S. Yeah, so del PD of S is equal to del PD by S in எழுதலாம் when you are going to apply step input in case of your response analysis. Now, what is your del F of S? So I am bringing minus sign to the Kp side. Minus Kp divided by the term 1 by STP Kp Kg T divided by R into 1 plus STG 1 plus STT into del PD by S. In place of del PD of S, replaced del PD by S. So I am going to apply final value here. So the static value of the system output is limit S tends for 0, S into del F of S. That is the relation. So we are going to substitute S which tends to 0. So I'm going to supply everywhere. So if you are supplying which is equal to 0 everywhere here, what are so first of all your S cancelled here. இந்த ரெண்டு S நான் கேன்சல் பண்ணிடுறேன். பண்ணிட்டு நான் S எல்லாமே அப்ளை பண்றேன். ஸோ இந்த டேர்ம் வந்து பார்த்து வேனிஷ் ஆயிடும். ஸோ எஸ்டிபி அதே போல எஸ்டிஜி போயிடும், எஸ்டிடி போயிடும். உள்ள டேர்ம் வந்து பார்த்தீங்கன்னா மைனஸ் கேபி பை 1 பிளஸ் Kp, Kg, Kd by R in del PD. So practically when Kg, Kt so my generator constant and turbine just replacing here. So my del F stat equal to Kp by stat static உங்களுக்கு அந்த ஃபைனல் வேல்யூ தியரம் அப்ளை பண்ணிட்டு எனக்கு கிடைக்கிற ரெஸ்பான்ஸ் அப்படின்றதுனால நான் ஸ்டாட்டிக் போடுறேன் Kp by R. So in the K by R, sorry, K I am replacing 1 by B and del P plus M. So mathematical காக மாத்திக்குவேன். The B na என்னன்றத பாருங்க. B is nothing but your load damping constant. So in problem the is provided. The damping constant given in terms of percentage. So a value of B equal to 2 means that 1% change in frequencies is a 2% change in load. So suppose B இருக்கு அப்படின்னா 1% frequency change ஆகும் 2% load ல இருக்கும். So your del PD but increase in load. Yeah, so that is replaced by M. So I am going to substitute here Kp on the minus 1 by B del PD as it is. The 1 plus Kp பதிலா 1 by Br. So இப்போ வந்து இந்த del PD வந்து minus M. So நான் ரெண்டு பக்கமும் வந்து numerator and denominator B ஆல வந்து டிவைட் பண்ணிக்கிறேன். So டிவைட் பண்ணிட்டேன் அப்படின்னா minus M B plus 1 by R மட்டும் வரும். So in the B plus 1 I am considering as beta. So minus M by beta. So beta is nothing but B plus 1 by R. So what is beta? Your area frequency response coefficient or characteristics in simplest AFRC in per unit megawatts per hertz. So the system performance change in power affects in frequency evaluated by AFRC. So your overall performance of the system is measured with the help of your beta value. So in practical, this beta is also considerably negligible. So B far less than 1 by R while neglecting B. So F stat equal to minus R del PD. So what is the overall response? Del F by del PD equal to minus R hertz per mega unit. So this is my final response uncontrolled case. Sorry. So what is R? It is speed regulation. As I told in the starting session, the parameter going to the operation of the system is speed. So based on your speed, the overall system get affected. So only we find as del F stat by del PD as R. Or otherwise I can write the del F equal to minus R into del PD. So it is a decremental change, speed regulation. So only I am putting here minus. So if I am applying the series, expansion series in case of standard deviation, so I may get a del PD by B plus 1 by R1 plus 1 by R2 1 by R power. So this is so on. So the drop of load frequency curve is here. So load versus frequency. We are just saying with your load and frequency, you have the linear characteristics. So once the load varies, the frequency varies. The frequency varies, load. So both have the mutual interaction. So ரெண்டுக்குமே வந்து பாத்தீங்கன்னா ஒண்ணுக்கு ஒண்ணு நம்மளுக்கு பாசிபிலிட்டி இருக்கிறதுனால I have the characteristics. So this is the speed load characteristics of your area system. So case number வந்து பாத்தீங்கன்னா uncontrolled case. கரெக்டா? Controlled case put வந்து 0 பண்ணிட்டோம். LPCR. Next வந்து பாத்தீங்கன்னா controlled case. Static analysis or static response of the area systems. Controlled case. So controlled case பத்தி படிக்க போறோம். So in control case, I am fixing my del PD as 0. பாருங்க. ஸோ பிடிஎஃப் வந்து 0 பண்ணிட்டு இந்த டேர்ம் எல்லாமே. ஸோ இப்போ கேஜ் டி கேபி டர்பைன் ஜெனரேட்டர் பிளான்ட் மூணுமே வந்து சீரீஸ்ல இருக்கு. வந்து 1/R இருக்கும். ஸோ இதுவும் வந்து நம்மளுக்கு என்ன ஃபீட்பேக் சிஸ்டம்? இட் இஸ் ஆல்சோ யுவர் நெகட்டிவ் ஃபீட்பேக் பிளஸ் மைனஸ் இருக்கு. ஸோ நெகட்டிவ் ஃபீட்பேக் சிஸ்டம் தான். ஸோ இங்க நம்ம அவுட்புட் வந்து del f of s by del pc of s. ஸோ kt divided by the end நம்ம 1/R மட்டும் மல்டிப்ளை பண்ணிக்கணும். ஸோ ஐ எம் ப்ரொவைடிங் ஹியர். ஸோ 1/R ஆல்ரெடி உங்களுக்கு ஜென்ரேட்டர் டர்பைன் கான்ஸ்டன்ட் ஜென்ரேட்டர் டைம் டிடியும் டிஜியும் 0. ஸோ அப்போ நம்மளுக்கு வந்து பார்த்தீங்கன்னா டிபி மட்டும்தான் இருக்கும், எல்லாமே 0 ஆகிடும். ஸோ நெக்ஸ்ட் ஸ்டெப்ல so I'm going to apply my step input. So PC of S del PC ன்னு apply. So apply பண்ணிட்டு I am just putting my S equal to 0 by applying final value here. So once I am applying, I may receive KP by 1 plus KP by R del PC. So KP வந்து நம்ம 1 by B ன்னு எழுதலாம். So in all case I am writing 1 by B divided by 1 plus 1 by B times of R into PC. So dividing and multiplying both sides by B. So 1 divided by B plus 1 by R times of del PC. So del F by del PC equal to 1 divided by B plus 1 by R. Hertz by megawatts. So this is the final expression for your controlled case. And third case, if controlling force del PC is applied to the speed changer and load demand changes by del P, the static frequency change is obtained by superposition theorem. So this is the how to apply cases, that is change of your incremental input, that is del PC to del PD. So del F stat equal KP by 1 plus KP by R del PC PD. So from equation I'm equating. So my del F stat equal to 0 and one case is del PC equal to del D. So if you are del F stat to 0, you may have the controller input equal to disturbance input. So what happens if I am applying this statement here? System made fast by reducing R. So once you are keeping reducing your R more and more, so the static loop gain should be increasing. And one more thing, my del stat equal to minus del PD by B plus 1 by, that is minus n by beta. By reducing R, left stat is also reduced. And third one conclusion is when TT and TG are neglected, the transient frequency dip is. So these are all the conclusions we obtained both controlled case and uncontrolled case. Any other doubts so far? That doubt irundha kekkalam neenga controlled case or uncontrolled case la உங்களுக்கு ஏதாவது புரியலனா கேளுங்க சொல்றேன். Do you have any doubts? இருக்கீங்களா எல்லாம்? Royce, are you there?
Yes, sir.
Okay. The doubt is either boy or girl. If you have doubt means you may ask. Why the people are so many people are not logging? உங்களுக்கு இன்னும் முழுசா வந்து ஒரு 3 மாசம் கூட இல்ல ஃபைனல் இயர் எல்லாமே முடிச்சு நீங்க பாட்டு எல்லாம்